In this tutorial, we're going to look at some examples of strip map interferometry with the Sentinel-1 Toolbox. A radar instrument actively emits a microwave signal and detects the reflection of the pulses from objects in its line of sight. This signal can be imagined as a sine wave which contains amplitude and phase information. Amplitude is the strength of the radar response. Phase is the fraction of one complete sine wave cycle, or a single SAR wavelength. The phase of the SAR image is determined primarily by the distance between the satellite antenna and the ground targets. Interferometry exploits the phase difference between two complex radar observations of the same area, taken from slightly different sensor positions, and extracts distance information about the Earth's terrain. By taking the phase difference of the two images after co-registration, an interferogram can be generated where phase is highly correlated to the terrain topography and deformation patterns can be mapped. Let's take a look at a first example. Let's open up two Sentinel-1 strip map products. You can see these are SLC, single look complex, and the product has complex data in the form of real and imaginary bands, here represented by the I and Q bands. When selecting data products for INSAR, you will need two or more level 1 SLCs for the same mode, track, and pass, as well as the same polarization. You will also want to pick products with long spatial baselines for DEM generation and short baselines for deformation mapping, and generally short temporal baselines to avoid decorrelation. The two products I have opened here are from the Napa Valley, California earthquake of August 24th, 2014. One product is from before the earthquake and the other product is after. This is the first earthquake measured by ESA's Sentinel-1 satellite. Let's click on the world map and then click on the product to snap to the location of the product and see its footprint, and you zoom in with the mouse wheel. Now if we go to the interferometry menu under SAR processing, we can click on the INSAR stack overview. Add products and view here the baselines. Okay, so let's go to one of these pre-built graphs. Under INSAR graphs here we have deformation pre-processing. And let's click on that. And what this is going to do is we're going to read in two products and apply the orbit correction and then create stack, course find co-registration and resample. This is the co-registration step. And then apply the interferogram and coherence and the subtract the reference step, and then apply phase filtering and finally writing. Okay, so in the read, we'll select the first band in one read and the second product in the other read, and then these we can all just leave as is. In the interferogram, we're going to subtract the flat Earth phase, and we're also going to add in the coherence estimation. And then we're going to write it out. So we're going to process this. Now let's open up the coherence, take a look at it, and the filtered phase. use the pan tools, pan around, zoom in, and here we see the fringes caused by the earthquake.